proving angle relationships. So we have a few new rules that we can use. We're not going to do any proofs today, but we will on the next video. The first one is angle addition postulate. So if we have a larger angle, say ABC, then we can say that is the sum of two smaller angles. So the measure of angle ABC is equal to the measure of angle 1 plus the measure of angle 2. Supplement theorem allows us to say that if two angles form a linear pair, then they are supplementary. The complement theorem says that if two angles form a right angle 90 degrees, then they are complementary. Really, this kind of sounds like the definitions of those things. The congruent supplements theorem says that if angles are supplementary to the same angle, then they are congruent. So if two angles are supplementary to the same angle, I can say that they are congruent in an example of this picture. Angle 1 and 2 form a linear pair. Angle 2 and 3 form a linear pair, so that means they're supplementary. Since they both form it with angle 2, then I can say 1 and 3 are congruent to each other, and the same rule applies for complementary. So if two angles are complementary to each other, then they are going to be congruent to each other. All right, so vertical angles theorem, we know the vertical angles, that kind of makes that crisscross, and we can say that vertical angles are congruent. And then we have a few right angle theorems. So one is that perpendicular lines form four right angles. So when two lines cross and form perpendicular lines, I have all right angles. I also know that all right angles are going to be congruent to each other since they're all equal to 90. And I know that if two angles are congruent and supplementary, then each is a right angle. If two angles are congruent and form a linear pair, then each is also going to be a right angle, and that's because supplementary and linear pair basically mean the same thing. Example 1. So if the measure of angle 1 is 23 and the measure of angle ABC is 131, we want to find the measure of angle 3. So if I take a look at this picture, the largest angle I see here is angle ABC. And it looks like if I were to add angle 1 plus angle 2 plus angle 3, then I am going to get that entire angle. So that's what I have here, that the measure of angle ABC equals the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. And I know some information about these angles. I know that angle ABC is 131 degrees. That's what it says in the given. Okay, the whole thing is 131. I'm also told that angle 1 is 23 degrees, so that would be this angle right here. But I also know something about angle 2. I see this little box, and this little box means that it is a right angle, so it is 90 degrees. What I don't know and what I'm asked to find is the measure of angle 3. So now all I have to do is really simplify this and solve like I'm in Algebra 1. So 23 plus 90 is going to give us 113. Okay, then I'm going to subtract 113 from both sides. And that's going to tell us that we have 18 equals the measure of angle 3. And since that's what I'm looking for, the measure of angle 3 is going to be 18. Just don't forget to actually, write out your answer. All right, so for example 2, it says that angle 6 and 7 form a linear pair. So what does a linear pair mean? It means that they add to 180. So the measure of angle 6 plus the measure of angle 7 should equal 180 degrees, and that's because it says linear pair. We also know some information. We know that the measure of angle 6 is 3x plus 32. And we know that the measure of angle 7 is 5x plus 12. So we can use this information to find x, which is one of our questions. And then we also need the measure of angle 6 and 7, so we can plug it back in. All right, so we'll combine like terms. 3x and 5x makes 8x. 32 and 12 makes 44. We'll subtract the 44 from both sides, and we'll get that 8x is equal to 136. And then we'll divide by 8, and when I divide by 8, I'm going to get that x equals 17. So let's make sure we put that in our final answer. And then we can use that 17 to find the other measures. So the measure of angle 6 was 3x plus 32, so that's 3 times 17 plus 32, which is going to give us 83. So 83 is the measure of angle 6. And I can do the same thing with 7. So the measure of angle 7 is equal to 5 times 17 plus 12. And when I work that out, I should get 97. And a good double check would just say, let's add 83 and 97 and make sure we get 180, which we do. Example 3. So it says angle 1 and angle 4 form a linear pair, and that angle 3 and 1 add to 180. We want to show that 3 and 4 are congruent. So if 1 and 4 form a linear pair, that means that they add to 180 degrees, and we see that right here. So we know that the measure of angle 1 plus the measure of angle 4 is equal to 180 degrees. Okay. I also was told right here that the measure of angle 1 and 3 is equal to 180 degrees. Okay. So now what I have to do is use these two pieces of information. Since they both equal 180, they equal each other. So I can say that the measure of angle 3 plus the measure of angle 1 is equal to the measure of angle 1 plus the measure of angle 4. So I can set these two equations equal to each other since they both equal 180. That's the transitive property. Now I'm going to subtract the measure of angle 1 from both sides. And I'm going to get that the measure of angle 3 is equal to the measure of angle 4. And if they are equal, I can say that they are congruent by the definition of congruence. Okay. All right, in number 4, it says that 2 and 4 are vertical angles. Okay, so we need to draw some vertical angles here. So here's angle 2, here's angle 4. If they are vertical angles, that means they are congruent, but it wants us to, without using vertical angle theorem, explain why are they congruent. So we could do this a few ways, but let's put in one more angle here. So I see that 1 and 2 form a linear pair, or they are supplementary. Okay. I also see that 1 and 4 are supplementary. So since they are both supplementary to angle 1 by one of these theorems we just had up top, two angles are supplementary to the same angle. Angles supplementary to the same angle are congruent. So that's the congruent supplements theorem. So I can now say that angle 2 and angle 4 are congruent by the, what do we just call it? The supplements. Sorry, I don't want to have the wording wrong. Sorry, the congruent supplements theorem. By the congruent supplements theorem. Okay. All right, for the next one, it says that ABE and DBC are right angles. We want to explain why these other two angles are congruent to each other. So if they are right angles, we know that all right angles are congruent, right? So we can say that angle ABC or ABE, is congruent to angle DBC, and that's because all right angles are congruent. That was a theorem we had. Okay, so ABE can actually be written as, here's ABE, the sum of two angles. We can say it's ABD plus DBE. So angle ABD plus angle DBE. Okay, so let's use the measures there. And we can say that is going to be equal to the other one. So here's DBC. I can say that is angle. The measure of angle DBE plus the measure of angle EBC. Okay. All right, from there, I can subtract DBE from both sides. That'll cancel out. So I get that the measure of angle ABD is going to be equal to the measure of angle EBC. And then from there, I can use, if they're equal, they are congruent. So angle ABD is going to be congruent to EBC, which is exactly what we wanted in the beginning. All right, last but not least, it says that ray DB is going to bisect angle ADC. So here's ADC. Okay. Here is my bisector. So that means that these two angles must be congruent. So we know that angle 1 is congruent to angle 2, and that's really by like a bisector theorem. Okay. We also can say that 1 and 3 are a vertical pair. Okay. So last but not least, if they are both congruent to 1, then they are congruent to each other, and that is the transitive property.